Hello, I am Arben Merkoçi. I am a career professor at Català Institute of Nanoscience and Nanotechnology. I am the director of Nano Bioelectronics and Biosensors group, trying to develop biosensors based on nanotechnology, nanomaterials. We develop sustainable biosensors, cost-effective devices that are for different applications, for diagnostics, from health to environmental monitoring. As simple representations of our devices, we develop lateral flow like a COVID test that people have been using during the COVID time, in which we apply nanomaterials, nanoparticles, or very simple standalone biosensors like, for example, the one that people suffering diabetes are using. And we're trying to develop brand new biosensors or improved biosensors that are taking advantages of nanomaterials, nanotechnologies. I'll show you now more details about the different research lines we have here at Català Institute of Nanoscience and Nanotechnology, with the idea to collaborate and do improvements, developments together for interest for our society.
Hello, I am Arben Merkoçi, and I'm going to show you what we are doing in Nano Bioelectronics and Biosensors group at Català Institute of Nanoscience and Nanotechnology in relation to nano biosensors for diagnostics. So we are at Català Institute of Nanoscience and Nanotechnology. We are a joint research center. This is why you see different logos of the different entities we belong. And we are situated in a very nice campus of Català. Here you can see our research center together with other research centers in the campus, ICMAP, CNN, Autonomous University of Barcelona, Synchrotron, ALBA is also here. In our group, we are trying to develop new biosensors based on the use of nanomaterials. We are trying to get advantages of nanotechnology, nanomaterials, to develop brand new nanobiosensors or improve existing ones, and so improve their performance, and trying to find interesting applications in the areas of health, environmental monitoring, safety and security, trying to also do technology transfer, and this is why we have two spin-off companies, PaperDrop and Graphenica Lab, that are generated by the technologies that we have been developing in our group. So we are developing different kinds of biosensors using paper-based platforms, simple devices like lateral flow, but also fully printed electrochemical devices using different kinds of nanomaterials, inkjet printing, graphene stamping, and other technologies, including smartphone connections, wearables, wireless readout with interest for different applications. So let me show you some devices, but first of all, what is the reason behind this research? So what are the challenges we have in this area? So first, the biosensors we are developing are very simple. I show here the case of glucose biosensor that you can find in any pharmacy in the world. We are trying to develop similar things, but of course with different formats, even wearable sensors. And these devices are very interesting because depending on the kind of receptor you are using, either enzymes, antibodies, or DNA strands, or depending on the transducer, so the way how the signal is employed and how this is transduced to a reading device, there are different formats, and we are indeed developing different kinds of technologies depending on the applications. So by the nanomaterials we are using, we have a lot of advantages in these nanomaterials, given their interesting properties, optical, electrical properties, and their size, usually between 1 and 100 nanometer. It is very, very interesting to see that these nanomaterials can work as building block together with the different biomolecules and analytes we are willing to detect in the different biosensor configuration. So we are working with quantum dots, we are working with metallic nanoparticles, but also other kinds of nanomaterials like graphene, etc. So biosensors nowadays are everywhere. You can see here a variety of application of biosensors. They are as medical devices, they are as wearables, smartphones, so everything smart. You see biosensors integrated in voice system for water monitoring, but also for food, plant control, smart houses, smart cities in the future. So you need biosensors if you want to do something. So before you need to detect and then to apply something, whatever, either therapy or if you want to do some remediation, you need first to detect. Otherwise, you cannot take any decision. And biosensors also can be very easily connected with the smartphone, and you see here some different interesting connections of smartphone with biosensors. One of them very interesting is this Google Glass, in which you see this guy is measuring lateral flow and of course the signal, so the imaging he is taking of this lateral flow is transmitted to the doctor office. So there are a lot of opportunities using also communication technologies. So the challenges in this area are various. I just want to mention the importance of development of cost-efficient devices, cheap, low-cost devices, sometimes disposable, because in this way you can achieve end users and they can really get advantages of these devices. With very expensive devices, it's really difficult, or which will be for use in the lab, but not for massive use application of biosensors. So in our group, we are taking advantages of all this variety of materials, platforms, substrates for different applications. We have been reporting interesting applications, not only for health, but also for environmental area, in which these devices have been shown to be very, very interesting for its interest for end users, for people without even expertise that want to use these devices. But why we need the fast and efficient diagnostics? And as an example, I'd like to take the COVID case that we have been dealing during 3 years. It has been an example that shows the importance of efficiency of diagnostics. So before taking any measurements, before taking any decision for treatment, we need to be diagnosed. So diagnostics is very, very important. And of course, these situations or the COVID pandemics have shown with a lot of infected people, and that's how crucial is the diagnostics, diagnostic tools for this reason. So in this review, in ACS Nano, you also can learn a little bit more how the development of these devices should be aligned with the research and development also we do together with the companies of science and business, trying to match this technology readiness level in a way that you can reach the scaling up and launching of the devices. So otherwise, your device, if separated from the work of a company, is very, very difficult to reach the market. So our idea in our developments and the kinds of technologies we are developing is to develop the so-called ubiquitous fabrication of nanobiosensors. So the idea is to go from centralized developments and technologies to ubiquitous. It means that instead of producing only in specialized places biosensors, why not to produce biosensors in any place in the world so they can immediately apply this in the case of emergencies. So you don't need to spend time to transport your sensors in different places because, for example, in case of viruses, they change very, very fast, and as fast as you can produce your devices is better. So the organization of diagnostics is very, very important, and in this context, nanomaterials, nanotechnologies with simple materials, but also in situ and easy production, low-cost scalability, portability of these devices, and overall sensitivity and reducibility and equipment-free sometimes is very important to reach the so-called democratization of diagnostics. So this is why we are also involved in a very interesting training projects to develop sustainable nanobiosensors in collaboration with our partners in the Català University in Albania, but also in Czech Republic. And together we are trying to get advantages of our expertise and trying to boost the development of these sustainable devices for our colleagues at the University of Tirana with interest, which are interested in development of nano biosensors for environmental monitoring overall for heavy metals, pesticides, antibiotics detection in water samples. So between the different devices, I'm just trying to show you some examples without entering details. For example, optical devices that we are developing. One of the most important representatives are lateral flow. So during the COVID, we also wrote this interesting nature protocol where we show a lot of details about this technology. So how you can design lateral flow, how you can prepare all the lateral flow, how you can prepare the nanoparticles, how you can modify these, do all the modifications, incubations, and then how you can run a lateral flow. And of course, what kind of nanoparticles you can use. Indeed, you can use from metallic nanoparticles to quantum dots, magnetic particles, and also very interesting is what kind of reading system you can use. In addition to native detection, you can also apply semi-quantitative or quantitative detection by using simple readers, including the smartphone. So this is an example we did of this kind of lateral flow reported several years ago, in which we show the use of graphene oxide in connection to quantum dots in a quenching phenomena to detect bacteria. So in this video you can see how this absorption. Afterwards, the quantum dots. These are famously tight quantum dots. Afterwards, you'll see these quantum dots that stand on top of this hydrogen composer are excited. You'll see exposing these to the invisible lamp. You'll see the nice electron coming from these photovoltaics coming from these. And afterwards, by using graphene oxide suspension, quenching memory, and we will do this probably soon by coming to the French suspension and probably absence. But really very system showing that messages also in this case. Then you can imagine that it changes. So we have been applying these devices for different applications. This is another case in which we use gold nanoparticles to detect some parathyroid hormone-like hormones in cancer cells with interest to develop some drugs. So we use in this case lateral flow for rapid testing of the efficiency of these drugs in this specific cancer. In this case, gold nanoparticles have been used combined with these antibodies against these biomarkers we wanted to detect. Also, during COVID, we did a lot of work and research trying to see and evaluate the efficiency of the antibodies. This is very, very important when you develop these kinds of devices. You need to be sure that you have the proper antibodies with the proper efficiency, and this is why we evaluated different antibodies from different sources and raised the important problem of the importance in cases overall of an emergency to have validated antibodies so as to be sure that we can set up devices that are working properly. So this is very important. We showed in this paper how important is evaluation and how to evaluate these antibodies to be used in the lateral flow system. Also, we are trying to connect the lateral flow with electrophoresis. This is something that we are doing also in some new projects for cancer diagnostics, in which we are trying to get advantages of lateral flow with electrophoresis. So by applying voltage using these the two electrodes here, we are speeding the separation and trying to get rid of the interferences. So by using this system, as you can see, even in the whole blood, we are able in very fast mode to improve the separation, getting rid of the interferences and improve the performance of the system in terms of sensitivity. Also in our group we have a lot of interest in home integration, and this is an example in which we set up a very interesting system, a kind of portable ELISA that is connected with a smartphone, in which we put together a ELISA plate, stepper motor, Bluetooth module using an Arduino board, and also some optical components, emission filter, lamps and the LEDs. So in a way that we are able to measure using this simple system different kind of analytes in different operation modes, in colorimetric, bioluminescent, turbidity measurements, and as you can see, all the system has been operating through a smartphone. So we have these devices offered for application in the field. So we have a kind of ELISA operating through a smartphone that's able to do different kinds of measurements of interest for different kinds of applications. So combining the potential of ELISA with the simplicity and portability of a smartphone for different applications. So all these paper-based sensors technologies in lateral flow are now in use by our spin-off company PaperDrop that is working now with hospitals, clinical partners to bring these technologies to increase their TRL and bring these to the end users. Also, we are developing electrical devices, and this is an example again of COVID in which we use some nanowires that are modified with some aptamers. These are like synthetic antibodies that are recognizing some, in this case, SARS-CoV-2 spike protein. So this is with interest for very sensitive detection of COVID 19 diagnostics, in which we took advantages of this electrochemical sensing using a very nice format. We call this binding induced conformational change, in which the aptamer is changing the conformation, and through a redox reporter we're able to follow up a nice electrical signal that is correlated with the protein we want to detect. Again, in combination with some, we call DNA nanotechnology, we are able to develop a programmable electrochemical shaped DNA in which the detection of antibodies and proteins in untreated biological fluids were being developed. So these are shown some details of the different conformations. We have been following, studying this, and again setting up onto a gold electrode this very interesting system that is detecting these antibodies, and we have a very nice change of the signal, electrical signal, that is possible to do the detection of the analyte we want, in this case, maybe an antibody, and of course this can be extended to different kinds of applications by engineering the DNA according to the application. We are trying to set up a whole system that is very simple, that is based using office printers even, in which we do, first of all, a drawing of our biosensor design. We load the nanomaterials in the printer, then we print our nanobiosensor, functionalize it with a aptamer that is specific to the analyte we want to detect, and after that, connecting this with a smartphone that immediately get the results. You can see here a schematic of the whole operation, so all the steps involved in this detection. This is an example related to the detection of NGAL, neutrophil gelatinase associated lipocellin, which is a biomarker related to acute kidney infection with interest for liver cirrhosis diagnostics. Also, we are moving toward the wearable devices, in which we have all the system integrated in a wearable. This is a simple case for copper detection, in which all the electronics is there, and we have the wireless communication of the data. In this case, we are applying electrochemical streaming analysis and trying to detect the copper in sweat, and also do some continuous monitoring of this parameter with interest for different diagnostic, but also in other configurations for environmental monitoring. So this is another example in which our devices are integrated in a boat, and this is for environmental monitoring in collaboration with our partners in the context of European projects, working with partners from Italy, Austria, and other places. We integrated our sensors inside this boat for the detection of different heavy metals. You can see here, for example, cadmium, lead, copper detection in different samples. There's been some applications in some rivers here in Catalonia, but also we integrated with our partners, experts in electronics and experts in this remote control. We both, our sensors were there, and this boat was going around and trying to detect contaminations by heavy metals, and then taking the data and transmitting this data so as to build directly the contamination maps, or send the results to the interested office. Also,
a dream, a drawing. Technology is on our side to capture what is buzzing around our imagination. It does not matter if it seems impossible. Why not invest in ingenuity, talent, and technology to achieve intelligent, versatile, cost-efficient, and robust solutions? Why not print our future?
Based on what you design, of course, in a computer, and then
this way, we can face all the challenges that appear day after day with new scenarios in such varying environments as transportation, logistics, home, office, or the internet. Graphenica Lab has succeeded in starting from the basis of graphene, the finest, lightest and strongest known material. The best heat and electricity conductor, almost transparent, flexible and elastic, an abundant element in nature, sustainable, and offering almost unlimited fields of application.
So this is a general overview of what we are doing in our group. If you need more information, you can read these reviews we wrote about the different topics, about the advantages of nanomaterials in designing a new generation of nano biosensors with interest for different applications, as I said, in different areas. Recent ones are related to the next generation of lateral flow, also using nanotechnology with interest for a lot of applications. I wish with this you get an overview of what we are doing in our group in relation to nano biosensors. I'd like to thank all our sponsors, our collaborators, but overall all the people of the group. Some of them are not here, so we are a multidisciplinary but overall international group with expertise in different areas. So you just write me an email or contact us if you need any information or if you would like to cooperate with us.